Shall we? Okay. So today we are going to start with the catalyst. So this is to 10.2. Okay. So 10.2 catalyst. Now first question is, what does a catalyst do? So catalyst is a substance that changes the rate of reaction. It means it can slow down the reaction or it can increase the rate of reaction. Suppose there is a reaction which is going from A to B. Okay. And to move it from A to B, it requires a specific amount of time. For example, it took 4 minutes to convert the whole A into B. Now, with the help of a catalyst, we can increase that rate, or that is, we can make it happen in 3 minutes. Or there may be a chance that with the help of a catalyst, we can decrease the rate of reaction. That means it can happen in 10 minutes or more than 4 minutes, whatever the time is there. So a catalyst is a substance that changes the rate of reaction without undergoing any permanent change itself. And itself, this catalyst would not change if it would not show any permanent change. Permanent change means basically it will not show any change. So it will not involve in the reaction, but it will increase the simply rate of reaction. Got it? Definition point. Now, the catalyst is not used up in the chemical reaction. The important point that catalyst is not used up. Suppose you use 2 gram of some catalyst. So the amount of catalyst remain unchanged. It is not like that it will hold used up in the chemical reaction. It is not a consumable thing in a chemical reaction. Second point, a catalyst may react with a reactant to form an intermediate or may provide a surface on which the reaction can take place. Now, catalyst may react with a reactant. Sometimes it reacts with a reactant and form an intermediate. Intermediate means it is sort of a middle thing between the product and the reactant. Okay. Or it provides the surface on which the reaction can take place. So catalyst will work in type of 2 things. That is, it may form an intermediate or it will provide a surface so that reaction will take place. Third point, at the end of the reaction, the catalyst is regenerated. So suppose if it reacts and form intermediate, then intermediate will give you a product and this product is formed leaving the catalyst. So we can say that at the end of the reaction, the catalyst is regenerated if it is formed an intermediate. Clear?
Yeah.
Okay, now a catalyst increases the rate of reaction by providing an alternative reaction pathway. So a catalyst increases, how we can say that the catalyst increases the rate of reaction? It increases the rate of reaction by providing alternative pathway reaction, which is having a lower activation energy. We know that for every reaction, there is a specific activation energy. For example, if you see enthalpy versus reaction of progress chart. So this is a graph. This is for an exothermic reaction. Why it is exothermic reaction? Reactant is having high energy and the product is having a low energy. So it means it is an exothermic reaction. Fine. Now, if a reactant will react only when they have a specific amount of energy. If this amount of energy is there in the reactant, then only it will convert into and give product after some time. Clear? So this pathway, this red wala pathway, this pathway is the pathway without any catalyst. It means it requires a little bit high amount of energy to do so. Fine. Now, if I add a catalyst in the reactant, what will happen? It provides a shortcut. You can see this a shortcut. This shortcut actually means a low amount of energy. So it gives the alternative pathway for a chemical reaction so that this decreases the activation energy. So with catalyst, we require a little bit less amount of energy so that a reaction can take place. Got it?
Yeah.
So a catalyst increases the rate of reaction by providing the alternative reaction pathway of lower activation energy. You can clearly see in this manner. Now, if you see in the case of endothermic reaction, in which the heat we require to provide heat, we have reactant, we provide heat without EA. This EA means activation energy, then it will again give you some product. And with the help of catalyst, if it is a catalyst one, and it is something like this. So it will again lower down. In both the cases, The main function of the catalyst is to lower down the activation energy so that the product can be achieved earlier. Got it?
Yeah.
Okay. Ji. Now we will study about type of catalyst. The first type of catalyst, homogeneous catalyst. Homogeneous means, homo means one single, geneous means phase. The catalyst which is having a single phase. So a homogeneous catalyst has same phase, same physical state as that of the reactant. Now suppose you have a reactant A which is solid, and we are using a catalyst which is also a solid. So both catalyst and reactant are in solid state. So therefore we can say that this catalyst is a homogeneous catalyst. Fine.
Yeah.
Now suppose A is a gas and again catalyst is a gas, then we can say that this is a homogeneous one. If A is solid and catalyst is not a solid, it is a gas, then this is not a homogeneous. This will become a heterogeneous. So a homogeneous catalyst has the same physical state as that of the reactant. The catalyst reacts with the reactant to form an intermediate. Now, in this case, the catalyst will react to reactant and form an intermediate. And after some time, this intermediate will break down and it will give the product and regenerate the catalyst. Here, now suppose
Yeah.
A, okay. Now suppose we have A which is solid in state, it will react with catalyst C, fine, okay, which is solid, and suppose it will form a AC intermediate. Now after some time, this AC intermediate will break down and you will get a, again A that is in different form. Clear?
Yeah.
Or suppose this is a B solid plus A solid, catalyst reacts with the A and forms something like AC, and then it also helps B to combine, and after some time you will see that AB is formed. Maybe, okay, I will show you, just give me a second. I will show. Is it visible?
Yeah.
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 And suppose A solid is there plus B solid is there. Okay, and we have a catalyst C solid. Now reactant and this catalyst is in same phase. So this CS is a homogeneous, it's a homogeneous catalyst. Here,
Yeah.
homogeneous catalyst. Now this C reacts with AB as a intermediate. So it will form something A, C, B. This is an intermediate. This is intermediate. Now after this intermediate, the C will be removed and it will form AB plus C. So you can see that this is regenerated.
Yeah.
Here, so in this way you can
Yeah.
clearly see, here you have C, A and B are reactant and this is an intermediate thing is formed. And after some time, AB is a product, this is your product, and C is regenerated. So catalyst is regenerated. Clear?
Yeah.
Okay. Now two examples of many reaction of gases and liquid flows, homogeneous or catalyst there. For the first one is making of ether with sulfuric acid as a catalyst. The equation below shows the preparation of ester, making of ester with the help of sulfuric acid as a catalyst. Now, if you see ester, that is CH3COO C2H5, this forms ethanoic acid, that is CH3COOH. This is ethanoic acid. Now, this is an ester. Now, esters are those compounds which are formed by the reaction of any organic acid as well as with the alcohol, with an alcohol. Okay, now see, I will tell, wait. Alcohol plus ORGANE, organic acid, it reacts in the presence of H2SO4 and give you ester. Here, so in this case, alcohol is also in aqueous form, organic acid is in aqueous form, and this H2SO4 is also in aqueous form, and you get ester which is also in aqueous form. So all are in aqueous form. So it means this H2SO4 is a homogeneous catalyst. Got it?
Yeah.
Okay, so you can clearly see C2H5OH liquid, C2HCOOH liquid, H2SO4 is also liquid, and it will form CH3COO, C2H5 plus H2O. This is also a liquid. Liquid or aqueous, you can write anything. So the reactant, alcohol and ethanoic acid, and the catalyst, sulfuric acid, all are in liquid state. Is that clear?
Yeah.
Okay. Now, ozone depletion, chlorine radical is used as a catalyst. Now, again, O3 is a gas, chlorine is a gas, and it will deplete and form oxygen O2, which is also a gas. So, this is also example in which we are having each and everything is in gaseous form. So, this is also a homogeneous catalyst example. Fine.
Yeah.
Now, see heterogeneous catalyst. Now, heterogeneous catalysts are the catalyst that has a different physical state from the reactant. Now, this heterogeneous catalyst is having a different physical state. It means the physical state of reactant and catalyst, they are totally different. Now, heterogeneous catalysts are usually solid in contact with the gaseous reactant or the reactants in a solution. So mostly in case of heterogeneous, we found that they are the solid ones, and generally the reaction taking place with them is nothing but they are gaseous reaction, or maybe sometimes it is a solution. Now these type of reactant molecules are adsorbed. That is the main, you can say, purpose of catalyst is to provide them a surface for a reaction. So the reactant molecule are adsorbed, weakly bounded onto the surface of the catalyst where the reaction takes place. So reactant molecules are adsorbed, weakly bound onto the surface of the catalyst. Okay, so what happens? Suppose this is a catalyst. Now reactant molecule form a bond with it, a weak bond with it. Okay, these are the reactant, and this is a catalyst. So they will form a weak bond with the catalyst. Here?
Yeah.
Okay, Ji. Now where the reaction takes place, and on this place, the reaction is taking place on the catalyst. Now after reaction, the product molecules leave the surface. Now suppose as the reaction takes place, how? As the reaction is completed, the product will move out. The product will move out, leaving behind only simple catalyst. Okay.
Okay. Yeah.
Now we have two terms, adsorption and desorption. Adsorption is a term which means absorption means that addition of reactant onto the surface of catalyst, and desorption means removal of product from the catalyst surface. So adsorption means addition, simply addition onto the surface of catalyst, and desorption means leaving of product from the surface of, leaving the, you can say, the product molecule leaving the surface of the catalyst is known as desorption. Clear?
Yeah.
Okay, examples we have in the case of ammonia formation. If you see making of ammonia, that in the Haber process, iron is a solid one, like N2 and H2. If you see nitrogen and hydrogen, both are gases, and in this case, iron is a solid catalyst which is used during the manufacturing of ammonia, and the whole process is known as Haber process. In this case, nitrogen and hydrogen adsorbed on the surface of iron, the reaction took place, and hence they leave in the form of ammonia. Now reforming, platinum and RH rutherfordium is used, like C6H14. They absorb on the surface of platinum and they form C6H12, and removal of H2 is there. Hydrogenation of alkenes, that is nickel solid, is used. Now in this nickel solid, hydrogen gas reacts with C2H2 and forms C2H6. That is addition of hydrogen is there. That is in the case with the help of nickel solid. Making of sulfur trioxide for sulfur contact process, and this also vanadium pentoxide V2O5 is used, which converts SO2 into SO3. So all these are the examples of heterogeneous catalyst in which Catalysts all are in solid phase, that is, they are in the solid state of matter, but the reactant are and the product are in the gaseous state. Clear?
Yeah.
Okay, जी. This you have to do. ये हमें करना है क्या बेटा? ये heterogeneous catalyst and atmospheric pollution.
No, I
Yes?
don't think so.
No? Sure? Confident? Okay,
Yeah,
so okay, I
it's
will.
just extra information.
Okay, fine. I'm leaving this. Then we have a catalyst, sustainability and economic importance. Now, what is the economic importance of catalyst and what is the sustainability of the catalyst? Now, it is estimated that 90% of all the reaction material are producing using a catalyst. Now, if you are, you can say, calculating the things, then 90% of the chemical materials are produced using the catalyst, and catalyst increases the rate of many industrial chemical reactions by lowering the activation energy. So with the help of catalyst, what it is doing, it is increasing the rate of reaction. And as the reaction of rate increases, and this how it is doing the reaction rate, by lowering down the activation energy. It means that there is a lowering of cost takes place. Now, if energy is less required, it means less expensive is there. So it will be less expensive, and if it is less expensive, it means we can easily get more profit. Then this then reduces the temperature needed for the process and the energy requirement. Now, as the activation energy is lowered down, which reduces the temperature requirement, and as the temperature during the process needed, which is less, so it means that the energy requirement for that maintenance of temperature is also less. Clear this point?
Yeah.
If a chemical process requires a less energy, then less electricity or fossil fuel is used, making the product faster. Using the less energy can cut the cost and increase profitability. That's why I already told you. So the economic advantage of using a catalyst outweigh the cost of associated with the developing of a catalyst process. So, and in this also, the advantage of catalyst is that, okay, now for making a catalyst also we require some sort of money, some sort of energy is required, but the amount of energy what the catalyst is saving, the economic advantage of using a catalyst is such that it outweighs the cost associated with the development of catalyst. Whatever the cost is there, if it is required to make the catalyst, is far less than what the catalyst helps in doing it. Clear?
Yeah.
Okay, Ji. Now the modern focus on the sustainability requires industry to operate process with a high atom economies and few pollutants. That they want that the pollution will be very less. Okay, and the economies will be high, or you can say the operated process with the high atom economy. So using the less fossil fuel will cut the emission of carbon dioxide and the gas linked to the gas which is linked to a global warming. So as the less amount of fossil fuel is used, so it means it will cut the production of carbon dioxide, and hence it is, you can say, will reduce the global warming. Clear?
Yeah.
Okay, now what about the auto catalysis? ये पढ़ना है?
The ones in the extra boxes, they're just like extra information.
Okay, fine. So, okay, just for information, I will tell you, auto catalyst, auto means self. Some of the reactants are self catalysis. Suppose, okay, have you ever seen your mom cooking, making curd? Have you ever seen your mom making it? So how she make curd? She use a little bit hot milk and put a spoon of curd into it and let it remain for some time. And after some time, you will see the whole curd will change. The whole thing will. This is known as auto catalyst. So curd is an auto catalyst. Means if you add a little bit amount of catalyst into any substance, and after some time you find out that the whole substance is now converted to the same. This is known as auto catalysis. So chemical reaction is said to have undergone auto catalysis if a reaction product acts as a catalyst for the reaction. Clear? If a reaction product is acting as a catalyst as a reaction. Typically reaction starts slow but speeds up as the product is formed. An example is MnO4 negative plus 16H positive in C2O4 minus 2 gives you Mn2 plus H2 and CO2. In this reaction, is very slow in the absence of catalyst. However, Mn+3 ion can act as a catalyst because manganese can easily change between the oxidation state of Mn+2 and Mn+3. So in this case, Mn+2 is used as a catalyst and which is also produced in the reaction. So in the first step, autocatalysis, the Mn+2 forms Mn+2 reduces to MnO, Mn+2 formed reduces MnO4 negative to Mn+3 as shown in the equation, and then Mn+3 then oxidizes the C2O4 and forms CO2, and again it reforms Mn+2. So in this way, it can be regenerated or it can be used. Here,
Yeah.
any doubt up to this point?
No, it's fine. Yeah.
It's fine. Okay. Now do one thing.
Yeah.
Quickly do these 3 questions. Quickly do these questions.
Okay. Yeah.
Okay.